is Visionary, a show exploring how nuclear powers your world. I'm Mary Carpenter.
And I'm Jordan Houghton. Let's jump in.
Hey, Jordan.
Hey, Mary. And hello, Visionaries. Thanks for being back with us.
Hey, Visionaries. Welcome to the final episode of Season 3.
I can't believe we're at the end of another season of Visionary. I feel like we just wrapped Season 2, and here we are again.
I know. It's been a great season, though. We talked about everything from saving rhinos to floating nuclear reactors, which is what we're talking about today.
Today's episode, we're talking to Mikal Bøe, who is the chairman and CEO of Core Power, which is a company focused on next-gen reactor technologies for the maritime industry. And Mary, I have to tell you, this conversation was really interesting to me because I think I've only thought about shipping like 3 times in my life. The first time was when Paris Hilton was dating all those shipping heirs, the Greek shipping heirs. She went through that phase. Mm-hmm. And then there was when the Ever Given blocked the Suez Canal. And that was like the multi-day, like how this is going to affect like global trade and shipping. And then when the cargo ship hit the Key Bridge in Baltimore. Beyond that, those are like the only times shipping was on my radar. And this is so interesting to me because when you actually listen to Mikal talking about the scale of shipping and the things that are delivered, you have this whole maritime network behind the scenes that is making our lives possible. And I feel like we just go on about our lives and we don't have to think about it because it just works and does what it's supposed to do.
I mean, I actually think about shipping probably more than the average person. I spent a lot of time in Savannah, Georgia, and there's the Port of Savannah.
Okay.
So you can literally sit at a bar or a restaurant on River Street, and these gigantic ships will go past just right in front of you. And so you're literally having a cocktail watching this gigantic ship go by. And the amount of containers on these container ships is... It's amazing to see how big these ships are and how much they're moving. And just to think about the journey that whatever's in these container ships are making across the ocean, it's pretty wild to see. So it's really cool. And it's really, really interesting that Core Power is working to provide clean energy for these ships. And you know, they're not only working on decarbonization, but also affordability and timing of how long it takes for goods to travel across the world. So you guys are going to really like this episode. It's really interesting.
Today, we're joined by Mikal Bøe, the chairman and CEO of Core Power, a company at the forefront of developing next-generation nuclear reactor technologies for the maritime industry. With more than 3 decades of experience in shipping, finance, and technology, Mikal has held leadership roles across the globe and now leads efforts to revolutionize shipping and sustainable nuclear solutions. He also serves in key advisory roles, including chair of the Maritime Applications and Nuclear Propulsion Working Group at the World Nuclear Transport Institute. Mikal, thanks so much for joining us today. We're really excited to have you on Visionary.
Thank you. I'm very happy to be here.
So I have to start out by asking, you originally studied business administration and performance arts with a focus on saxophone. What led you to pivot toward a career in the maritime industry?
That's a good question, and it's a long time ago. So, Jordan, when you get a chance to go to one of the foremost music schools, you sort of sit there and think, shall I do it or shall I not do it? And it always comes down to, will I regret having done it or will I regret not having done it? And the answer is pretty obvious. So you do it and you have a go. And I realized that it wasn't for me, like so many musicians, realized that, this wasn't something that I was going to make a living out of. So I, like most Norwegians, end up either in oil and gas or in shipping. And I ended up in shipping.
So tell us a little bit about your career so far and what has been the most rewarding part.
Well, it's hard to pick one thing because, I think my career over these last 30 years have really been one where I've tried to learn as much as possible about everything that, I was involved in and doing, and taking all of that together and starting a company 6 years ago. In fact, it's our 6th birthday today, so we just had a little birthday party in the office. But putting that all together, learning about finance, learning about, ocean transportation in all forms and everything that comes with it, and learning about risk management, learning about technology, learning about how you put things together, how you take things apart, and how you defend them. I think created the foundations for being able to start Core Power to really answer that biggest of questions that the shipping industry has had since we went from sail to steam, in the 1870s. And we've got to do that again now. How do we do that? And there's a big gap in the market. I started the company because I felt that all the things that I'd done in my career and all those things, all the low points and all the high points and all the things that I'd learned was really, in totality, something that would be sufficient to be able to start answering that big question. How are we going to go? How are we going to change the way ocean transportation is powered?
Happy birthday to Core Power.
Yeah.
Thank
Happy
you.
birthday.
That's very exciting. So nuclear-powered ships have historically been associated with icebreakers and naval fleets. With Core Power's mission to decarbonize ocean transport, how do you see this technology transforming commercial shipping?
Well, Jordan, the essential part of the logic of setting out to build a maritime civil nuclear program as opposed to a naval nuclear program is that the technologies, the reactor technologies, the advanced light water reactor that's used by the Navy, and that's also used by all the nuclear navies, and of course is what the Russians are using on their icebreakers, is what you're referring to, is technology that we can't use. We can't use it in commercial shipping, and it's the reason we don't have nuclear ships on the water today. And people think it's something to do with safety or something to do with public perception or economics and these sort of things. But it's actually about something very simple, and that is insurance. The fact is, we can't take a mobile light water reactor into a port because we can't insure it. It cannot be commercially insured as a mobile unit, and therefore we can't use them on ships. And as a result, that technology, which works beautifully for navies and for icebreakers, the Russian icebreakers, remember, are trading only inside of Russian waters, and the dispensation to do so. They don't come out of that. It is the fundamental thing. So we see this generation, so this next generation of reactor technology, some of which are able to meet those criteria for commercial insurance, and that's kind of why we're involved in developing those technologies, is really what opens that up. So once we can get those to market, get them licensed, get them permitted, get the regulatory regime in place, get the supply chain and the finance and the workforce built in this program to start putting those out into commercial shipping, all of a sudden now you've got that first spark of a new era of global trade. And I think that's the big thing here. So there is an essential difference between the way we do things on the military side and the way that we will do things on the civil side. But, I'd also like to stress that it's incredibly important that these two things coexist. And they coexist, so naval nuclear propulsion, maritime civil nuclear propulsion coexists with the common grounding in safety culture and the common grounding in the kind of high level of integrity that's required in order to make sure this is done right. It can't be just, some random solution that is put out there. It has to be done right, and it has to be done the right way. And I think that's really what the program is all about.
So I want to back up just for a second for our listeners and hope that you can explain what exactly we mean by nuclear-powered ships. How does this work?
So nuclear-powered ships are effectively ships with a reactor on board where that reactor acts as the energy source, the fuel tank. Remember, ships today they have an enormous amount of space on board for fuels, and that those fuels now tend to be, if you like, the stuff that's at the bottom of the barrel after the oil refinery is taking everything out. So it's sort of the sludge at the bottom of the barrel. Shipping industry is the waste management arm of the oil and gas industry. That's effectively what we are. And all of these fuel tanks then, contain you separate fuels because you don't want to commingle them. You separate fuels from different delivery places, and then they're fed into a very large diesel engine, which then obviously, turns the crankshaft, turns the gearbox, turns the long shaft, turns the propeller. So it's a very simple kinetic system. Nuclear propulsion really has the reactor as the fuel tank. So we don't have fuel tanks on board the vessel anymore. It's a heat source which is then exchanged into either directly through a steam generator into a gearbox that turns the propeller, or it becomes a nuclear electric system, which is really what we're favoring. Because if we go the old-fashioned way, which is the most efficient way, which is to take reactors, take the heat, turn that into steam, turn a turbine, turn a gearbox, turn a shaft, turn a propeller, the entire installation is a nuclear installation. So everything from the propeller tip all the way through to the core of the reactor is considered a nuclear installation. And I don't think that's the way to go for commercial shipping. We need to separate these two things. So we'd expect to have the reactor inside, if you like, one of the cross sections of the vessel. Ships are built, almost like like a loaf of bread, right? All these slices together. And one or two of those slices would then be nuclear grade, nuclear island, and then we would exchange that heat for a turbo machinery sitting in the power conversion section of the vessel, which would then generate electricity, which would be distributed out to various parts of the ship. And that gives us certain advantages. One is we can go away from this idea that we have to have, a direct connection to a shaft drive, which turns one single propeller. And some of these ships are absolutely enormous. We can now go towards, twin propellers or even triple, different configurations of how we can power these ships depending on what kind of ships they are. So it creates efficiencies in ways that we just can't do with the technology we have today.
Are you seeing interest from customers?
Oh, absolutely. I mean, this is the most extraordinary thing, Jordan. So, when I started this company 6 years ago, I'd say there were 2 or 3 people that I met that thought it was a good idea. But those are people I trusted. And I genuinely believe that. There's a survey that comes out every year that asks shipping industry executives, what's the future look like? And this year, 21% said nuclear propulsion is the future and it'll be with us within 10 years. Last year, it was 9%. The year before that, they hadn't even asked. And I think it masks an underlying, because it depends who they ask, right? But it masks an underlying trend here. But I think close to 50% of those that are long-term investors in shipping, and remember, it's a multi-generational industry, have now moved from that, maybe nuclear is an option, if nuclear, that kind of thing, to, okay, nuclear is the way to do this. Now the question is, how do we do it? And so you move from if to how, and that's a massive seismic shift that we've seen in this industry. I mean, amongst our shareholders, we've got shareholders in Core Power which are all strategic industry shareholders, big shipping companies, big shipyards, shipping banks, trading houses, cargo owners, really the industry behind it. And they collectively control more than 5,000 ships, which is about 8% of the global fleet. So yeah, I think that speaks volumes to that question. I think there is a massive amount of interest from customers, and it's growing because they're starting to get engaged in that sort of conversion from if to how.
What do you think has contributed to this shift in support?
There's a couple of things. I mean, not least of all the work that we've done over the last 6 years of spending time with the industry individually and collectively in fora, in offices, in boardrooms around the world, explaining how this works. It's not an industry that understands nuclear very well. Shipping doesn't speak nuclear. Conversely, nuclear doesn't really speak shipping either. So we've acted as a kind of interpreter in this and being able to explain nuclear to the shipping industry, but similarly being able to explain shipping and ocean transportation to the nuclear industry. And there's a real meeting of minds here. So I think there's a couple of things that have contributed to that. That's one of them. But it's also because international regulations, the United Nations through the International Maritime Organization, is basically said to the global shipping industry that they've got to cut 70% of all airborne emissions by 2040. That is an unsurmountable challenge of scale. Just almost impossible to imagine how you would do something like that if you're starting to nibble at the edges of energy efficiency and fuel substitution, that kind of thing. You need a radically different way of thinking about it, because by 2050, we're supposed to be at or near zero. And I think there's only one way to do that, and that's with a strong nuclear component.
What do you think sets nuclear energy apart in terms of like the shift in support? What do you think sets nuclear apart compared with options like hydrogen or biofuels?
It's an interesting way of looking at it, Jordan. I mean, the laws of nature speak for themselves. And, personally, I think this green shift, this green agenda that's washed over us over these last few years has got an awful lot of hopium in it. there's a lot of wishful thinking. There's a lot of expectation that shortcuts are going to be available to us, that this isn't going to be as hard as people think. And, gradually over time, people realize that that's just not the case. I mean, this is difficult. You don't get to do these things the easy way. The key difference between, if you think of the fuel source that we have in shipping today, which is that it's called an intermediate fuel oil. So it's a 380 centistoke sludge. Is a carcinogenic, foul-smelling sludge that comes out of the bottom of the oil refinery. And very good fuel for massive diesel engines. We get about 42 megajoule per kilo of energy in that. If you then move towards synthetic fuels made from hydrogen, it has to be green hydrogen, otherwise, we're trebling or even quadrupling emissions for using hydrogen production through steam methane reforming. For doing green hydrogen, effective electrolysis of water, then we combine that with either captured carbon, which I think is an illusion, or nitrogen to create ammonia, which has been brought forward as a fuel. We're down to between 17 and 19 megajoules per kilo. So if you're going to get the kind of power that you need out of a big diesel engine to move big ship across the Pacific Ocean, you're going to need to use close to 2.5 times as much fuel. So energy density really matters here, right? So if you compare just a standard uranium fuel to ammonia as a fuel, you're looking at a 4 million times the amount of energy per kilo or per ton, or whichever way you'd like to look at it. And that just changes the way we think about energy effectiveness, the way we think about waste, the way we think about the entire system around this. In addition to ammonia being a low energy fuel, it's also exceptionally toxic, right? It's liquid at minus 33 degrees centigrade, and anything above that, it wants to be a gas. And in small quantities, that gas will kill pretty much whatever it comes into contact with. So, we've got to be very careful what we wish for here. In many ways, if the industry moved towards green hydrogen-based fuels, that's the best thing that can happen for us, because they become so ridiculously expensive that nuclear just becomes ridiculously cheap. And that's something we all want, right?
I'd love to hear more about what Core Power is working on.
Yeah, so like I said in answer to one of the earlier questions, the overall thing that we're building is a program. So we're building a maritime civil nuclear program, and that program is focused in the OECD. So we think of our competition as being China, and we think of our competition as being Russia. We don't think of our competition as being other reactor companies. I think we coexist very well with, serious reactor companies or reactor vendors out there. It's the program that matters. That program has two outputs. The first output is a floating nuclear power plant, and the second output is a nuclear powered ship. So maritime civil nuclear propulsion on one side and floating nuclear power on the other. The common engineering between these two allows us to build these systems in shipyards. That's the big difference, I think, for the nuclear industry. When I was referencing earlier, nuclear being interested in shipping is not so much necessarily just for propulsion. It's being able to use, large-scale shipyard manufacturing to deliver nuclear on time and on budget. We've been looking at these announcements like everyone else has this year, with the big data companies, the big AI companies coming in and wanted to get into nuclear, wanted to invest in nuclear, wanted to buy nuclear. And the big question is, how do they do that? How do you buy nuclear? Somebody's going to have to build your power station. Somebody's going to have to take that risk of first-of-kind power station construction, civil construction, time overruns, cost overruns. It's the bane of our life, right? Thinking about how we do big construction. If we can move to a fully modular system, if we can move to 100% modularity, and we can move to mass assembly, and we can have repeat construction, the learning curve comes down rapidly. The innovation cycle speeds up. It accelerates very, very rapidly. And of course, as a result of that, you start to be able to substitute that economy of scale that we're used to with the economy of numbers that you get through repeat construction. Of course, quality assurance comes as a benefit of this as well. The more you do it, the better you get at it, the better the product, et cetera, et cetera, et cetera. So I think for floating nuclear power plants, the idea is that you could deliver, a nuclear power plant to a customer at a guaranteed date. If somebody said, okay, I'd like to buy one of these things, and we say, well, okay, you can have it on the 27th of February, 2032. That's the day they expect it to turn up. And the nice thing as well about floating nuclear power plants, of course, that you've got some flexibility in where they're located. They can be towed to site. They can be permanent installations in ports and terminals and islands and remote locations, etc., providing that energy security that's required in those places where the supply chain for energy is so tricky. I think on the other side, there's maritime civil nuclear propulsion. So that idea of nuclear powered ships is something that uses the very same principles, but now you're coupling the energy system to a propulsion system. So now the reactor is perpetually mobile. So you're now moving that around with the ship. So, and that's obviously always going to be a challenge when you think about the whole world. But if you think about specific trade routes and you think about terminal to terminal type of operations, which, to be fair, a lot of the large commodity value chains, the industrial components and durable consumer goods value chains are milk routes, right? These are standard trading routes. You trade from Tokyo Bay to Long Beach. You trade from the Middle East to the United States. You trade from South America to Europe. You trade from Australia to Japan, South Korea, etc. And these are ships that just go up and down, across and back, the same boring thing all the time. You can create these conditions for nuclear-powered ships to really insert a whole new future for those value chains. That changes the nature of how the ship fits into that value chain between the shipper on one end and the receiver on the other. And of course, ports and terminals play important parts. That's where the rubber meets the road, right? So you've got floating nuclear power plants helping non-nuclear ships take electricity from shore, powering gantry cranes, loaders and dischargers, all that kind of thing. Ports are quite energy-intensive places. And then ships that can come in and intermittently do that if you're able to connect those power systems to a mini-grid, for example, in the ports. Now ships are providing a much greater, economic benefit to the value chain that it serves.
Are there specific shipping sectors or regions where you think nuclear might gain traction first?
I think we have to think of it that way. As per the United Nations, there are 102,147 ships on the water today. But that's everything over 500 tons, which basically makes it a very large sector of small ships. If you think of shipping, international deep sea shipping, it's about 65,000 ships that burn about 300 million tons of fuel oil, and about 7,000 of those ships burn about 50% of that fuel oil. So if you're now thinking of segmenting this, the first segmentation that you would perform would be size of ship and power requirement. So if you take the very larger ships, these are big super tankers, these are big, massive ships and bulk carriers that carry iron ore and grain and that kind of thing. And then you've got the big container ships, even medium-sized container ships. They require a lot of power and are predominantly engaged in these repeat trades. They're not tramping, as we call it. They're not taxis and Ubers. They don't go everywhere, right? The smaller ships do that. These big ships trade between these specific points of contact. And that's the sector we think is one that comes in first. Now, if you segment that further and you look at which one of those trades is likely to be the first movers, you'd probably want to start somewhere which is in a nice friendly area. And that could be, transatlantic, for example. We haven't had pirates in the Atlantic since Jack Sparrow was a scourge, right? You'd probably want to try and get into some of those container shipping, like trans-Pacific container shipping. I mean, that at current rates takes from Tokyo Bay to Long Beach is, north of 14 days. You could move that down to 6.5 days if you're able to speed ships up and get them back to where they should be. That changes the nature of that value chain again, right? You get you much better just-in-time distribution and get you much better access to reliability of that supply chain that you rely on coming from other parts of the world. So I think container shipping, dry bulk shipping, to an extent, maybe tanker shipping, but the irony of totally decarbonizing a super tanker is not lost on many people. So we'll see. I think it probably starts in dry bulk and container shipping, but with the large vessels.
I want to go back to something you just said for emphasis. So we are talking about this largely in the frame of decarbonization, but you just mentioned speed. Can you talk a little bit more about that? Like, is that another benefit to moving in this direction? You're able to cut shipping times because the ships can go faster?
It is, Jordan. And it's not as true in all segments as it is in others. So, whether you have 300,000 tons of iron ore arrive on a Tuesday or on a Friday or on a Sunday is not as important as if you've got containers full of industrial components and durable consumer goods that are being moved between markets. So speed and time is more important in other segments than they are in others. But what's actually happening, you have to think about this relatively, right? So ships are built with an optimum speed and consumption profile. And the speed and consumption profile is usually the one that, is the sort of optimum performance of that vessel. What's happening in the global fleet today, and it's been going on for decades, is that the fleet is sailing at a very, very reduced speed across the ocean. So tankers and dry cargo vessels that are designed for 14 knots are sailing at 10, 11 knots. Container ships designed for 26 knots are sailing at 17 knots. And they're doing the save fuel inside of those freight calculations that you do when you do cargo. So fuel is easily 40% of the cost of moving a ship across the ocean. So going slower reduces that fuel consumption on Pacific voyages, and as a result, that's often what the industry is doing. So the industry has slowed down. The additional benefit of that, of course, is that as you slow the fleet down, you're effectively removing supply from the market and you're holding rates up because supply-demand balance is in your favor. If you then go to nuclear, you don't have to do that. You don't have to slow down to save energy. I mean, all the energy is there for you to use anyway. So you can now start competing at higher speeds with ships that are slow. If you're going to go down the route of synthetic methanol or synthetic ammonia or biodiesel, the sheer cost of those fuels are going to be prohibitive in the speed calculation. So you're going to have ships that are carrying less cargo because they need to carry more fuel. They're going to have to go slower because it's so expensive to burn those fuels. And you're effectively going to have an industry that then takes a few steps back in order to try to decarbonize. I think the thing with nuclear is that, you solve both sides of the equation. I mean, decarbonization itself isn't really the aim. The aim is to be able to do that whilst remaining economically competitive. I mean, if we can't afford to do it, we're not going to do it. So we have to solve for both sides of the equation. We have to solve for the environmental issues. We have to solve for the economic side of this. And the economic side of it is really what drives it all. So nuclear does both. It allows you to, maintain that hyper competitiveness in the market whilst emitting nothing. And as a result, people are starting to realize, and you asked before, is there interest in the shipping industry? Absolutely. I mean, this is the solution. We just got to get it right.
So talking about affordability and decarbonization, can you go back to something you mentioned a little earlier? I'd love to hear a bit more about how floating reactors can provide clean power to islands and remote areas.
Yeah. So floating nuclear power plants constructed in a shipyard would come out of that shipyard just like anything else they construct, whether it's a ship or a barge or some sort of offshore platform. And you would then tow that to a site. So an island, take a Pacific island or a Caribbean island or a Mediterranean island, you would then locate that floating power plant either depending on what the water conditions are around it, right? Either on a long jetty, so it would sit on a jetty out into the ocean, or you would have it connected directly to shore. It sort of depends a little bit on seismic activity in the area, what the weather is in that area, etc. But you could effectively install a smaller, so you're talking about something that's about 160 meters long, about 35 meters wide, weighs about 20,000 tons. You could connect that on a terminal or on a jetty or on a berth in a small port somewhere and would sit quite comfortably there, or you can create that on that island. You'd hardly notice it's so small. And that would just sit there as a permanent installation. Now then, once that needs refueling, as a 100% modular system, right, fitted onto a barge-like structure, that barge is moved to a refueling station, to a home yard, if you like. It's not done in situ. So then you would replace that with another floating nuclear power plant. So you'd have an identical model would turn up, and then that would be swapped around. So the turnaround time, which would proxy the refueling, would be very short. And then you would take that floating nuclear power plant off to its home yard, be serviced, maintained, refueled, etc., and then brought to location in another place. So you'd have this fleet optimization of nuclear power that you could distribute to the right place. It also gives you flexibility then in how you scale this, right? So you started with, say 30 megawatts electric, and you needed 60, or you can either double it or you can bring in a larger system as you go. But it allows people to start buying nuclear directly and on time and on budget. So, having that collaboration then with operators, nuclear operators, utilities in the area that can then say, okay, we can take these systems and we can deliver that to our industrial customers and our communities. And we can do it in a way that, doesn't create an enormous financial overhang risk for everyone. I think it's just what we're looking for.
What timelines are you looking at? Like, when do we expect to see these things up and running?
That's always a very hard one to answer, Jordan.
I know.
You see what I mean? I think our focus is more on getting this right than doing it quickly. And I think if we try to do it quickly, or we try to promise that we can do something really quickly, people are going to be let down and disappointed. I think on some of these propulsion systems, the larger systems like that, we would expect to see demonstration of this in the mid-30s. Scale deployment would then come after that. But I think it's important to recognize that, the investor base that's pushing this forward, or rather pulling this forward, are quite patient. They don't need a solution tomorrow. They need a solution for the next generation, right? And that, when you have a multi-generational shipping company, we have shareholders that have got, 500 ships that are in the fourth generation of ownership, right? There's a question of what are you handing to the next generation, and how are you investing for that to happen? Taking a risk on not keeping up with modern times and solving the problems of tomorrow is something that they acutely aware of. So I think it's the ability to demonstrate and show how this is then going to work, properly, not just technologically, but in every possible way. How do you train the workforce? How do you maintain the supply chain to be able to service and maintain and fix problems as they go along, and have those facilities up and running? How do you have the sort of no gaps regulatory framework in place that allows you finance and insurance and all these things? Demonstrating that by the mid 2030s, I think, is realistic, and I think it's extremely powerful. That's going to unlock an awful lot of things. Remember, shipping is a $14 trillion a year industry. It's not short of money. What
excites you the most about the future of nuclear-powered ships and floating reactors?
The most. I'm so excited about all of it. Mary,
it is exciting.
I just get excited about about the whole thing. The most exciting thing about this, honestly, I think to facilitate the possibility of something truly unique happening in the future, something that, changes the way we move stuff around the world, right? 80 to 85% of everything that's exported is moved at sea. It touches every single part of our life, and it has to evolve. It's always evolved. it is one of the oldest professions in the world, right? It's always evolved, and it will continue to evolve. And I think this is it. This is the thing that's going to move the needle and take us into a new era. Just the thought of that is exciting, and being able to be part of that and setting up a company that, draws on an investor base and a fantastic talent pool and partnerships and, supportive governments and agencies, etc. is nice. I fall off my chair twice a year now.
If we have listeners who are hearing all of this and they're feeling a little bit nervous thinking about nuclear powered ships and floating power plants all over while we're going about our everyday life, what would you say to them to help instill confidence in the safety of these technologies?
I would say, I'd like to have a long conversation with every one of them to explain how this works. And they'll, and to be fair, everyone I have spoken about this so far has said, okay, I get it. All right. It's not what I thought it was. I think there's a couple of things that is important for people to remember. And one of them is that this perception that nuclear is so dangerous, and that if something sank to the bottom of the ocean, that it would be some sort of disaster, is an illusion, right? The oceans contain roughly 4 billion tons of uranium and has background radiation like everything else. They're enormous. And the way that we design not just the system, but the safeguards, the security wrap around the safeguards and the safety around that again, to these exceptionally high standards set by the NRC and potentially other, grade 1 nuclear regulators, combining that with the grade 1 maritime regulations and safety and security standards that are out there. You're designing to, it's like air travel, it sounds so ridiculously dangerous to sit in a metal can doing, 500 knots across a city, but it's one of the safest things that we have. I think we'll have to get to a point where people realize that even in the very worst case scenario, this is orders of magnitude less impactful to the environment and to anything else than, an accident involving an oil tanker or a chemical tanker or, a fire on board a car carrier and all these sort of things, right? So I think we need to get over this. We need to get out of our own way a little bit and the way we think about, how if something goes bad, if something goes wrong with a reactor system, that it is somehow some sort of disaster. It isn't. I mean, most of these things are complete fender benders, not disasters.
And I have to imagine the benefits of clean powered shipping would be significant for the ocean and sea life.
Yeah, I mean, you're not polluting the oceans either, and diesel-powered ships not just polluting the atmosphere, they're polluting the oceans too. So you've got to weigh up the benefit versus the perceived risk of what that's there. I mean, nothing's perfect. You can't get away with something that doesn't produce any waste at all. You can't create something that's 100% safe in every condition that's out there, but you can mitigate for those risks, and we can absolutely warrant that if one of these ships were to break up and sink and would go down to the bottom of the ocean, that would not be an environmental incident. It would stay in its box. The fuel would stay in the reactor would stay in its box, and it would be there safe forever, I think.
Okay, last question. We're asking all of our guests, what was the last show you binge watched?
Slow Horses.
Oh.
That is
okay.
one of my favorites. Love it.
Slow Horses.
All right.
It has that wonderful sort of protagonist, underdog bravery, I think, that I truly admire. And I think, the cast of actors was fantastic. That John Le Carré type story in there. So I absolutely love that one. I wish they'd make more of those.
It seems like the next season is actually filmed already, but they're just not going to release it until next year. I love that. That is one of my absolute favorite shows. So,
well, I don't know if you come to London often, but it's filmed here in this town, and it has a very London feel to it, which is also quite nice, right?
It's a good one to add to the list. Well, thank you so much for joining us today. This was such an interesting conversation. How can our listeners follow along with Core Power's journey?
We have a website, corepower.energy. We have a fairly active LinkedIn profile for the company that, posts things that are going on in the industry, and we try to sort of keep informed that way. We've set up an NGO called the Nuclear Energy Maritime Organization, NEMO. Yeah, we think it's quite a cool name. And that's now, gaining NGO status at the IGOs. So anyone who really wants to be involved in this should get involved with NEMO. That's all the regulatory side, it's standards and licenses and all the other things that need to be together the framework. But then as a company, our website is a good place to start. And of course, you can contact me at any time. It's lovely talking to you guys. Thanks very much for having me on.
Thank you.
Thank you.
That was a great episode. We're so appreciative that Mikal took that time with us. I loved it.
So many things to think about from this episode. Really interesting. Mary, if you have not watched Slow Horses, you need to add it to your list. It's a really great show.
Yeah, I have not. And I'm always looking for new shows. See, this is what we're trying to do with this season. Maybe we'll keep doing it next season because I'm actually really enjoying it.
It's great. So to our listeners, thank you for another amazing season. We couldn't do it without you. We can't wait to come back for season 4.
Hope you learned a lot this season. I hope you had fun with us and hope you got some new show ideas.
If you enjoyed the show, as always, we'd love to hear from you. Send us a comment. Let us know who you'd like to hear from in season 4, and support the podcast by subscribing on Apple, Spotify, or wherever you listen.
Thanks, Visionaries. See you next season.